roll forward some more features, right? Because if you're just fixing bugs forever, things aren't moving forward. Um, so one of the things that's been requested that I procrastinated on early on, simply because the projects people were making weren't really that big yet, was module features. More specifically, like what are the pragmatic aspects of how modules work, right? And so modules are this programming language's version of, well, they're sort of like header files that you would have in a standard library like C or C++, but they're also like libraries, right? Like precompiled libraries like you would have in C or C++ together, because we don't really have headers as a separate thing. And also because we try not to have that much in the way of precompiled binaries, because that adds complexity, and the presumed optimization that you get from that is not really meaningful when your compile times are actually as fast as they should be with modern computers. So the vision of the language for a long time has been that these modules would be a relatively decentralized thing. Because the model that happened in the C and C++ world sort of organically grew over a long time, I think, into what is the wrong model, right? Like back in the C days, in the earliest C days especially, like the headers were just sort of what you needed to interface with the operating system, and or maybe do some user level stuff like strings and files and all that. But those were all things where, depending on what system you were deploying on, the interface with the operating system may reach more or less into those varying things. Like there wasn't a lot in the very original C headers about like, this is just a high level library that we're providing to people, right? And so it made sense for those headers to be distributed with the compiler, and installed on your machine globally, right? And C++ inherited that approach, but now C++ is providing tons and tons of high-level functionality that has nothing to do with your operating system and really doesn't need to change. But there are lots of, but they're still being deployed, installed on your hard drive with the compiler, right? And there are lots of negatives about that, right? One, it means that compatibility has to be maintained because you need to be able to expect to download a program and compile it, right? And that puts a lot of constraints on what those libraries can be and how they can, and really how clean they can be and how understandable they can be. Because a lot of times, one of the major things you can do to make things more understandable is just to massively refactor it to work differently. And if you're just not allowed to do that ever, you get what we have today, right? In those languages. Another negative aspect is you don't really feel free to change things, right? Like the philosophy in C and C++ that sort of happened naturally as a result of this is that, the file function fopen is not something that you could change if you wanted to, right? Maybe I want to change fopen, right? Like who are you to say that I can't change fopen? But it is just not a thing that is thought of, because it's just annoying to try to do, right? You get other things that crept more into the realm of more practical day-to-day problems, like, using your own malloc is annoying and all these things, right? Okay. So that's one paradigm that I don't think is the right one. Of course, other programming languages have had another paradigm, which I also don't think is the right one, right? So like in JavaScript or whatever, every time you like compile or build or whatever, it looks at all the dependencies and grabs them all and makes sure you're up to date with the newest one and whatever. That's also pathological in several ways. One way is, again, libraries are not really allowed to change very much. They have to be very careful because it's expected that your newer version just drops in and replaces the old version, right? And again, that's honestly, that is one of the worst things you can do with regard to code quality long term, is to fix things like that. And then especially like you have in the world of JavaScript and some of these other scripting languages, where you have very small granularity of imports, you not only fix these abstraction barriers with very defined semantics, but you fix them over like very small nuggets of code, right? So very little is really allowed to be done, apart from making a whole new, library somewhere. But then you've got this proliferation of stuff that all does the same thing. And if you just want to know what to use, you don't really know, right? Like, I think some choice is good, but, pathologically trivial choice is not good. Also, just with regard to reliability and with regard to, let's just say reliability, I want to be able to pull my program out of the closet in 20 years, and I want to be able to compile it, right? And I want it to work. A lot of the other features of this programming language are designed in that way. For example, the whole metaprogramming system, right? Like the program defines its own semantics. You don't need to rely on external tools being particular versions or whatever else, right? So, if you expect to pull down packages over a network onto a fresh machine in order to compile your program 20 years from now, you have no idea. Okay, so first of all, you have no idea if the internet 20 years from now looks like the internet of today, or if it's super balkanized or whatever, right? If you're in an emergency situation, you may not have internet, and you may want to be able to compile things. Like there are many aspects of the way people are building some of these ecosystems that are, in my opinion, firstly, very unwise, but secondly, fragile, right? And so the goal is to be robust. And so the plan for the module system is to do what I think a couple of other languages have done, which is to say, look, if you're building a large application, what happens is the quote, what the kids call these days, the dependencies, just get pulled into your application, right? So you would have, a modules subfolder next to your build subfolder or whatever. And whereas the build subfolder just gets temporary files, right? Like, here's files for debugging and like object files and stuff. Your modules folder just gets whatever you import, right? And that has two effects. One is it's very robust, because that code to open a file is like in your module subfolder, right? So it's going to be the same code to open a file 20 years from now. You can change it, right? You can modify it in your local copy, and you don't affect the system copy. So that gives you a lot of agility with regard to just making things work the way that you want it to, that you don't have in other programming languages. Of course, then you have sort of the job of, how do you manage that change clerically? Like, how do you make sure you don't overwrite it with a new library and all that? But all that stuff is in your control, as opposed to the programming language or the operating system's control, right? The other thing it does is it just makes you aware of how much code you're using. And I think the number one problem with software today is you have all these people who are programming, and they literally have no idea what code is ultimately used by their program, right? Whereas if all the code is right there, you can see what it is, which is great for learning and understanding your system, which I think we all need to do more of. But it's also good for making sure it's minimized, both the size of the system and the complexity of the system. You might look in there and say, what is this module? Why is it being used? Oh, it's being used because I'm outputting colors to the console, and I use this thing that used this other thing to do that. Can that be done more simply, right? I think these are all good things in the long term. So, oh yeah, I could have made my face bigger while I was doing all this. Let me do that, because there's nothing on the window yet. Ta-da. Okay, so that is going to be the first major feature addition is just going to be better module handling. So there's a couple aspects to that. One aspect is just a simple one. Well, okay. There's parts that have been figured out and parts that have not been figured out. So the parts that have been figured out are the ones I've been talking about. How does that work? Well, there's going to be, a module subfolder in your application folder, and you would control how that works with the build options, right? In the same way that your metaprogram can set build options normally, there'll be a subset of the build options that's about modules, and it'll say, hey, what's the name of your modules folder, right? And then there'll be an enum of what's the policy for modules, and you'll be able to pick between, like always use system headers only, which I'm not sure why you would ever do that, but that'll be one of them. Use system headers, but copy them into my local folder if they're newer, if the system headers are newer, right? Or use system headers, but copy them into my modules folder always, or just use my module folder and never use system headers, right? There'll be at least those 4 options. And so, I expect particular workflow for a large application would be something like, and also import headers into my application only if I don't have any version of those, right? Which is probably going to be the default. So if you're writing a new program and you just want to import like, BASIC and, OpenGL and a few other things, then the default policy would copy those down the first time, but then probably not update them after that. That said, right, so one of the things you do when you're maintaining a large program is you want to explicitly say, okay, now is the time when I want to update my libraries, right? Because you don't want to do that all the time while you're developing a large program, because you've got real problems that you're trying to solve. You're like trying to build software, so you don't want stuff breaking all the time, right? But then once in a while, you're like, oh yeah, if I updated my font rendering to the newer version, I would get better layout for particular languages and stuff. It's time to do that. So let me check that off my to-do list and do that, right? And so basically, the ability would be there for you to tell your metaprogram to just maybe update a particular library, or honestly, it's probably a lot simpler to just do the file copy yourself, right? You go into your modules folder, you rename the old one to whatever .old, and just copy the new one in, right? I actually would like to default to that kind of thing wherever possible, rather than having magical compiler stuff that just does copies and renames and things, because when there's a big complicated system of copies and renames and things, again, you need to understand that if you're going to do anything about it. And the tendency becomes for people not to understand and not to do it, right? Whereas if the policy is just, look, if you want to update a library, the simplest thing to do is go in and just move the thing over, right? That leads to people understanding. It leads to a certain kind of system transparency, right? And so we'll see exactly how that turns into. We'll see if, if you don't run a meta program, right, are there going to be command line options to do some of this? Maybe, as the beta users know, there's a very minimal set of command line options right now. And whereas I'm not generally opposed to adding more, I am opposed to adding a lot more, because I don't want it to turn into something like a typical C compiler in that respect. Okay. Oh, and then another simple thing that people have been asking for is, how do I add more module paths, right? So right now, when you use a program, it pulls things from system libraries only. If you're writing a module, like people who are writing modules have this problem where, right now it wants to import them from the system folder, but their module isn't being deployed with the compiler, so they have to copy it there or whatever. And there's currently a single module path, but we'll probably make that more robust. And then the question is how does that interact with the other thing I was just saying about the policy of what to use when? And we'll see. I can imagine different ways of doing it. Okay, so that's the next big feature beta. I don't have an exact date on that, but hopefully it's not too long. Because honestly, it's not that hard. It's just been something that I've been holding off on, while we did a bunch of other things. Like we only recently got struct literals that were any good. So, one thing at a time. Okay. So then the next